While we've been talking about limits, we've mentioned an important fact, that the limit of a function as we approach a point does not necessarily equal the value of the function at that point. I want you to take a minute to try and graph a few functions where at some point the limit of the function is not the same as the value of the function. You've already seen some of these in class, but go ahead and pause this video and try to doodle some different scenarios. Probably the things you've come up with look like one of the following. So let's talk about them. The first one, and this kind of seems like the cheapest example, we could take some nice, well-behaved function and just remove a point from it and put it someplace else. In this example, as x gets closer and closer to 2, f of x also gets closer and closer to 2, so the limit of f of x as x goes to 2 is 2. But the value of the function at x equals 2 is actually 1. So the limit of the function and the value of the function differ when x is equal to 2. You can also have a kind of jump in your graph. It's nice to the left of x equals 2 and it's nice to the right of x equals 2, but there's this kind of cliff in between and the graph is somehow broken. So although the function has a value at x equals 2, its limit as x approaches 2 does not exist. Finally, you can have the function shoot off to positive or negative infinity. A function can never take on infinity as a value, so if the limit is infinite, certainly the limit is not the same as the value. Now I want to ask you another question. Can you think of a function that has lots of these spots? In particular, can you think of a function where in infinitely many places, the limit of the function is not equal to the value of the function? Here's a bonus harder question. Is it possible to have a function on the reals, so the kind of function we're used to defined for every real number, where at no place its limit is defined? What that means is there's no place where there's even a tiny little plateau in the function making it predictable. The function is defined everywhere, but no matter which point you choose, the limit at that point does not exist. Is it possible?